All right, we're back. We are on page 173 of math analysis. We are talking about conic sections. We've talked about the circle. We talked about the ellipse. And if you remember, an ellipse has like a lot of stuff. There's 7 things. There's an equation, a center, vertices, covertices, foci, eccentricity, and area. 7 things. Now we're going to talk about the hyperbola. If you remember, an ellipse is the set of all points in a plane, the sum of whose distances from 2 fixed points is a constant. Turns out the definition of a hyperbola is really similar to that, but kind of like the opposite. So a hyperbola is the set of all points in the plane, so it's still that. The difference of whose distances from 2 fixed points, which are called the foci, is a constant. So it's the difference between the distances. So there's horizontal, there's vertical. I'm going to show you in GeoGebra right now just like what that kind of means, the whole like difference between the distances. So I'm going into that. I put a link, I think there's a link in all the videos descriptions to this GeoGebra book. They call it a book. It's a collection of like activities or sketches or whatever. And I'm on the hyperbola difference of distances. So I know it's pretty small. This is finding the difference between them. So the distance from focus 1 to point P, and the distance from focus 2 to point B. It's finding the absolute value of the difference between those. And right now, one of those distances is 2.56, one of them is 5.03, and the difference between them, the absolute value, is 2.47. So now if I move this point, you can see like here, the distances are 2 and 4.47. The absolute value of the difference though, 2.47 still. And it's just gonna stay that. And that's kind of the amazing thing. And there's 2 different branches. So in GeoGebra, what you do is you just like drag it over and eventually it jumps. I guess it's like right when you cross the axis there, right when you cross like, well, you'll find out that's called the conjugate axis. The axis that passes through the foci or the vertices. So you got all the same things. You got foci, vertices, covertices. Covertices don't show up anywhere. But these are all things that we had with an ellipse. We have them also here. So your foci, right here, point P is currently at one of the vertices. The other vertex is over here, right? So they're on the same line. The vertices are on the hyperbola. And then the hyperbola looks like it's kind of, I would say it's eating the foci. So it's eating the foci. So this is a horizontal, what's called a transverse axis. So instead of a major axis, you have a transverse axis. We're going to go over all this again. But just like move it around, see it's the difference between them. So you can compare that to the ellipse where it was the sum of the distances, right? So we have 2 distances. You can incidentally, you can make an ellipse if you want to. You get like a piece of cardboard and 2 like thumbtacks and you put the thumbtacks in and then you take string. So you need to have like all these things. You take string, you tie it on each thumbtack and then you take your pen and you just like pull the string taut and then go around and you'll get your ellipse. So it's kind of fun to make. I don't know, I feel like I did it in an art class actually, not really a math class, but you can do it. So this is our hyperbola, it's got 2 branches. Let's go back to the notes and see what we can kind of say about these. So if you know what you're doing with an ellipse, you basically know what you're doing with a hyperbola because almost everything is the same. So you'll notice right away, the equation looks really similar to the equation of an ellipse. One major difference, I guess I should say, is that we have a minus instead of a plus. Well, think about the definition, right? The definition for an ellipse, it's the sum of the distances, and then there's a plus in between these 2 things. Here the definition is it's the difference, and there's a minus. So a hyperbola will have a minus here. You might notice A and B don't change position, right? For an ellipse, A is always bigger than B. And you can tell if it's horizontal or vertical based on where A is. So if A is underneath X, then it's horizontal. If A is underneath Y, then it's vertical. For a hyperbola, it's kind of the opposite. A and B don't move. There's no specific relationship between the sizes of A and B. A could be smaller than B, A could equal B. Then you get like a visually pleasing hyperbola. And A can be bigger than B. It doesn't make a difference. Well, it makes a difference in the graph, but like there's no fixed relationship. What does happen though, is A and B stay where they are. X and Y will move. So if X comes first, right, the X axis is horizontal. If X comes first, we have a horizontal transverse axis, which means that the foci are on a horizontal line. The vertices are on a horizontal line. It's eating a horizontal line. So I always say eating. I mean, that like sounds weird and maybe looks weird, but like you got to kind of do it. Like eating vertical, eating horizontal, like you have to do that. And when you do it, you get a better sense. So here, vertical, I can tell it's going to be vertical because y comes first. The most common mistake that I see people make is that I see them, they'll switch x and y successfully, but then they forget like h always goes with x, k always goes with y, and the center is always hk. So the center will always be hk. So what have we got so far? We got a minus sign. We know there's a and b are always where they are. They don't change places. And if x is first, it's horizontal. If y is first, it's vertical. So let's like label this up a little bit. So everything is the same name. So this is a focus, a vertex, a covertex. There's nothing special, by the way, about like 1 and 2. Like how to switch those numbers and you're totally fine. So this distance is, oh gosh, why am I so bad at this particular part? Okay, here, this distance is a. So the distance from the center to the vertex is always a. The center is still, the center for every conic, well, kind of, is hk. If a conic section has a center, its center is hk. I'll say it that way. Because a parabola doesn't really have a center. Like, feels like it does, but it doesn't have a center. So the distance from the center to a vertex is a. From the center to a focus is still c. And from the center to a covertex is still b. Nothing has changed. So that's pretty nice. I knew this was going to be, I knew it was going to be horizontal, which means it's eating a horizontal line, or it has a horizontal transverse axis. So the transverse axis is the horizontal line basically that runs from vertex to vertex, focus to focus, or just like through the vertices and foci. I knew it would be this because x came first in the equation. So that's a thing you got to look out for. What else do we know here? I mean, I feel like that's like pretty much all you need. Now, a hyperbola has a weird feature that an ellipse doesn't have. I mean, it has a lot of weird features that an ellipse doesn't have. It has 2 branches. You know, that's weird. It also has asymptotes. So the asymptotes for this are y minus k equals plus or minus b over a times the quantity x minus h. Don't memorize that. The reason I'm telling you not to memorize that is that you can take this and turn it into that. The way you do that, and this, it's kind of a trick, but it's also not really a trick. For the asymptotes, what you're gonna do, and you end up doing this in your head basically, is you change the 1 that the equation is equal to into a 0, and then you solve, right? So 0. So when I solve this, I'm gonna just copy and paste a little bit. Actually, I'm gonna, all right, here's what I'm doing. I'm gonna copy, duplicate you, do this, right? So what I basically do is I just move in my head, I move this over to this side. So now it's like plus that. Then what I'm gonna do is I'm gonna move this over here, right? I'm gonna multiply both sides by that. So I'm gonna go for it. Trying to duplicate again, duplicate, right? So here, but now b squared is up in this numerator because we cross multiplied. Now I'm gonna square root both sides. I get y minus k equals plus or minus, and then it's gonna be b over a x minus h. So you do not need to memorize that because that's a process. If you do it enough times, you're just gonna get it, right? So what do we got? We got vertices are A away, covertices are B away, foci are C away. You can see in the picture, C has to be bigger than A for sure, which means the eccentricity, which is C over A, will always be greater than 1. These are the sorts of connections that you want to try to make. So what words have I said? All right, they're going to be written down here. A couple of words that I said. The vertices are on the transverse axis. So let me start highlighting. Vertices are on the transverse axis. Covertices are on what's called the conjugate axis. So the transverse axis is really similar to the major axis of an ellipse. So think like transverse is basically major. Conjugate is basically the minor axis. But since A doesn't need to be bigger than B, the transverse axis might be shorter than the conjugate axis. So like the word major and minor seem to imply a relationship, whereas transverse and conjugate don't really imply that. So that's why we're using those. Another key thing, I know I'm like all over the place on this, I'm just like shooting information at you, but it's because they're so similar to ellipses and we like spent that time. To figure out C, it's literally the Pythagorean theorem. So C squared is A squared plus B squared. That is awesome because it's easy to remember. Also, remember an ellipse, plus in the equation, finding C, there's a minus. For a hyperbola, there's a minus in the equation, but to find C, there's a plus. So you get this like swap. So it's just easy to remember. It's not easy to do or anything, but it's easy to remember. So let's see over here. So I could tell that this would be vertical because Y is coming first. Vertical means eating a vertical line. So the foci are on a vertical line, vertices are on a vertical line. So this is going to be a vertex. This will be a focus. This is your covertex. And then, so think about your distances, right? This must be B. This must be A, which means that this is 2A. This is your transverse axis. And then this must be 2B. This is your conjugate axis. So your conjugate axis goes between covertices, C and C. That's pretty nice. The foci are going to be C units away. I don't really have a spot for that, so I'm not gonna put it. One thing that I will show you though, look at these asymptotes, right? So the asymptotes seem to go through the corners of a box that has, I'm looking for a good color to highlight, and maybe let me make my highlighter smaller. Okay, they go through the corners of a box that has dimensions 2B by 2A. This is going to take me way longer than you want it to take me. I don't think you can make the highlighter make a rectangle. Nope. Well, maybe, but I am not skilled enough to do it. So this box, I call it the asymptote box. The asymptotes are the diagonals of this box. The box is 2A by 2B. The midpoints of the sides of the box are the vertices and covertices. And so when we go to graph, this is going to be one of the main features that we need to get down. We need the asymptote box to look right. So what do we got? We got like everything, right? So there are still 7 things. So is there anything in here that we need to cover? Foci are definitely, man, I don't know. Should I remake this video? I definitely don't want to, but I definitely am all over the place. The foci go with a transverse axis. The asymptotes, you're going to change the 1 to a 0 and solve. You're basically, what you're really doing there is you're really taking advantage of the degenerate case, which is a pair of intersecting lines. So these intersecting lines are the asymptotes of this particular hyperbola. And standard equation has a minus and C has a plus. We're going to make the asymptote box. So find everything for these means 7 things. And they're almost exactly the same, right? Equation, center, vertices, covertices, foci. All of those are exactly the same. Eccentricity, exactly the same. The 7th thing is going to be the asymptotes. For an ellipse, the 7th thing is the area. For here, it's the asymptotes. So it's going to be all 7 of these things. And you just got to remember them. But, you know, because you get to graph it, it's not as hard to remember as maybe you're thinking. Anyway, that's a lot of information. I'm going to come back in the next video and do some problems because I think it's easier to do problems than to talk about it, really, despite the fact that I just talked about it forever. So I will be back in the next video to do problems, and I will see you there.